Replacing a 100 amp main breaker indoor panel involves several steps to ensure safety and proper functionality. Firstly, disconnect the old panel. This involves turning off the main breaker and any individual breakers. Use a voltage tester to confirm that power is completely off before proceeding. Once the power is off, carefully remove the cover of the old panel. Next, disconnect all the wires from the breakers and the neutral and ground buses. It's essential to label each wire before disconnecting it to ensure correct reconnection to the new panel. Install the new 100 amp main breaker indoor panel in the same location as the old one. Ensure it is securely mounted and properly grounded. Splice all neutrals and grounds to reach the new bus. Use appropriate sized wire connectors and ensure each connection is tight and secure. Connect the wires to the corresponding breakers and the neutral and ground buses referring to the labels you created earlier. Double check all connections to ensure they are tight and properly seated. Close the panel cover and secure it with screws. Turn on the main breaker and then each individual breaker one by one. Verify that all circuits are functioning correctly. Label the panel with a circuit directory indicating what each breaker controls. Clean up the work area, removing any debris or tools. Replacing a 60 amp AC disconnect requires similar attention to detail. Firstly, turn off the power to the AC disconnect at the main panel. Use a voltage tester to verify that the power is off. Remove the cover of the old AC disconnect. Disconnect the wires going to the condenser. The wires may be burned up if the old disconnect has failed. Install the new 60 amp AC disconnect in the same location as the old one. Ensure it is securely mounted and properly grounded. Connect the wires going to the condenser to the new disconnect. Verify all connections are tight and secure. Turn on the disconnect. Label the disconnect with its purpose. Clean up the work area. Installing a can light involves connecting the fixture to the existing wiring. Firstly, turn off the power to the circuit at the main panel. Verify the power is off using a voltage tester. Connect the wires from the can light to the corresponding wires in the ceiling box. Typically, this involves connecting the black wire to the black wire, the white wire to the white wire, and the ground wire to the ground wire. Verify all connections are tight and secure. Turn on the light at the main panel. Verify the light is working properly. Label the light switch with its purpose. Clean up the work area. Replacing a deck or a receptacle requires disconnecting the old receptacle and connecting the new one. Firstly, turn off the power to the circuit at the main panel. Verify the power is off using a voltage tester. Remove the old receptacle from the electrical box. Disconnect the wires from the old receptacle. Connect the wires to the new deck or receptacle, ensuring correct polarity. Typically, the black wire goes to the brass screw, the white wire goes to the silver screw, and the ground wire goes to the green screw. Verify all connections are tight and secure. Mount the new receptacle securely in the electrical box. Turn on the power to the circuit at the main panel. Verify the receptacle is working properly by plugging in a device. Clean up the work area. Remounting a dryer receptacle involves securing it back into the wall and ensuring it is properly connected. Firstly, turn off the power to the dryer circuit at the main panel. Verify the power is off using a voltage tester. Carefully pull the dryer receptacle out of the wall. Inspect the wiring for any damage. If there is damage, repair or replace the wiring as needed. Securely mount the dryer receptacle back into the wall. Verify all connections are tight and secure. Turn on the power to the dryer circuit at the main panel. Verify the dryer receptacle is working properly by plugging in a dryer and testing it. Clean up the work area. When working with electrical systems, always prioritize safety. Turn off power at the source before working on any wiring. Use a voltage tester to verify that the power is off. Wear appropriate safety gear such as insulated gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician. Remember to always follow local electrical codes and regulations. Ensuring all connections are tight is crucial for preventing electrical hazards. Loose connections can cause arcing, overheating, and potentially fires. Use appropriate tools, such as screwdrivers and wire strippers, to make secure connections. When splicing wires, use appropriately sized wire connectors. Follow the manufacturer's instructions for proper installation. When connecting wires to terminals, ensure the wires are properly seated and the screws are tightened securely. After completing any electrical work, thoroughly inspect all connections to ensure they are tight and secure. Testing the functionality of electrical devices after installation is essential to ensure they are working properly and safely. For receptacles, use a receptacle tester to verify proper wiring and grounding. For lighting fixtures, turn them on and off to ensure they are functioning correctly. For appliances, plug them in and test their operation. If any issues are found, troubleshoot and correct them before using the device. Labeling electrical panels and disconnects is important for identifying circuits and equipment. Use a circuit directory to label each breaker in the electrical panel with its corresponding circuit. Label disconnects with the equipment they control. This makes it easier to identify and troubleshoot electrical issues in the future. Proper cleanup of the work area is essential for safety and professionalism. Remove any debris, such as wire scraps, insulation, and packaging materials. Sweep or vacuum the area to remove any dust or dirt. Dispose of any hazardous materials properly. Store tools and equipment in a safe and organized manner. By following these steps, you can safely and effectively upgrade electrical panels, replace AC disconnects, and repair electrical fixtures. Remember to always prioritize safety and follow local electrical codes and regulations. Ensuring tight connections, testing functionality, labeling equipment, and cleaning up the work area are all crucial for a successful electrical project. Additional points to consider when working with electrical systems include grounding, bonding, and surge protection. Grounding provides a path for fault current to flow back to the source, helping to protect against electrical shock. Bonding connects metal parts of the electrical system together, creating a low-impedance path for fault current. Surge protection protects against voltage spikes that can damage electronic equipment. Regular maintenance of electrical systems is important for preventing problems and ensuring safety. Inspect electrical panels, disconnects, and fixtures for any signs of damage or wear. Test ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters, FCIs, regularly to ensure they are functioning properly. Replace any worn or damaged components. Keep electrical panels and disconnects clean and free of obstructions. By following these maintenance practices, you can help to keep your electrical system safe and reliable. If you are unsure about any aspect of electrical work, consult with a qualified electrician. They can provide expert advice and assistance to ensure the job is done safely and correctly. Remember that working with electricity can be dangerous, so it is always best to err on the side of caution. When selecting electrical components, choose high-quality products that meet or exceed industry standards. Look for products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, AL, or Electrical Testing Laboratories, ETL. Using high-quality components can help to ensure the safety and reliability of your electrical system. When running new wiring, follow the National Electrical Code, NEC guidelines for wire size, conduit, and installation methods. The NEC provides comprehensive information on how to safely and effectively install electrical wiring. Consult the NEC for specific requirements for your project. When working with aluminum wiring, use connectors and devices that are specifically designed for use with aluminum. Aluminum wiring requires special handling to prevent corrosion and ensure proper connections. Follow the manufacturer's instructions for installing aluminum wiring connectors and devices. When working with knob and tube wiring, exercise extreme caution. Knob and tube wiring is an older type of wiring that is often found in older homes. It is important to have it inspected by a qualified electrician. Consider replacing knob and tube wiring with modern wiring to improve safety and reliability. When working with underground wiring, use appropriate burial depths and wiring methods. The NEC specifies minimum burial depths for underground wiring based on the type of wiring and the location. Use direct burial cable or conduit to protect underground wiring from damage. When working with swimming pools or hot tubs, follow the NEC guidelines for bonding and grounding. Swimming pools and hot tubs require special electrical safety measures to prevent electrical shock hazards. Consult the NEC for specific requirements for swimming pools and hot tubs. When working with generators, follow the manufacturer's instructions for installation and operation. Generators can provide backup power during power outages, but they must be installed and operated safely to prevent electrical hazards. Use a transfer switch to prevent backfeeding power into the utility grid. When working with solar panels, follow the NEC guidelines for wiring and grounding. Solar panels generate direct current (DC) electricity, which requires special handling to prevent electrical shock hazards. Consult the NEC for specific requirements for solar panel installations. When working with wind turbines, follow the manufacturer's instructions for installation and operation. Wind turbines generate electricity from wind power, but they must be installed and operated safely to prevent electrical hazard. Consult the manufacturer's instructions for specific requirements for wind turbine installations. Understanding basic electrical concepts is essential for working with electrical systems. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical current. Power is the rate at which electrical energy is transferred. Ohm's law states that voltage equals current times resistance. Understanding these concepts can help you to troubleshoot electrical problems and make informed decisions about electrical work. Using appropriate tools and equipment is essential for working with electrical systems. Use insulated screwdrivers, pliers, and wire strippers to prevent electrical shock. Use a voltage tester to verify that power is off before working on any wiring. Use a multimeter to measure voltage, current, and resistance. Use a wire gauge to determine the size of wires. Use a conduit bender to bend conduit. Using the right tools can help you to do the job safely and efficiently. Following safety precautions is essential when working with electrical systems. Always turn off power at the source before working on any wiring. Use a voltage tester to verify that power is off. Wear appropriate safety gear such as insulated gloves and eye protection. Work in a well-lit and dry environment. Avoid working alone. If you are not comfortable working with electricity, hire a qualified electrician. By following these safety precautions, you can reduce the risk of electrical shock and injury. Maintaining a clean and organized work area is important for safety and efficiency. Keep tools and equipment organized and readily accessible. Remove any debris from the work area. Sweep or vacuum the area to remove any dust or dirt. A clean and organized work area can help you to stay focused and avoid accidents. Inspecting electrical components for damage or wear is important for preventing problems and ensuring safety. Look for cracked or broken insulation on wires. Look for loose connections or corroded terminals. Look for signs of overheating, such as discoloration or melting. Look for damaged or worn-out switches and receptacles. Replace any damaged or worn-out components promptly. Documenting electrical work is important for future reference and troubleshooting. Keep a record of all electrical work performed, including the date, location, and description of the work. Include a wiring diagram of the electrical system. Store the documentation in a safe and accessible location. Having accurate documentation can help you to troubleshoot problems and make informed decisions about future electrical work. Testing ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters of size regularly is important for ensuring they are functioning properly. GFCIs protect against electrical shock by detecting ground faults. ASICs protect against electrical fires by detecting arc faults. Test GFCIs and ASICs monthly by pressing the test button and verifying that the device trips. Replace any GFCIs or ASICs that fail the test. Continuing education is important for staying up to date on the latest electrical codes and technologies. Attend electrical training courses and workshops. Read electrical trade publications. Stay informed about changes to the National Electrical Code (NEC). Continuing education can help you to improve your skills and knowledge and provide the best possible service to your customers. When selecting wire size, follow the NEC guidelines for ampacity. Ampacity is the maximum amount of current that a wire can safely carry. The NEC provides tables that list the ampacity of different wire sizes based on the type of insulation and the ambient temperature. Choose a wire size that is large enough to handle the expected load. When selecting overcurrent protection devices, such as circuit breakers and fuses, follow the NEC guidelines for sizing. Overcurrent protection devices protect against overloads and short circuits. The NEC provides guidelines for sizing overcurrent protection devices based on the ampacity of the wires they protect. Choose an overcurrent protection device that is properly sized for the circuit. When installing electrical boxes, follow the NEC guidelines for box fill. Box fill refers to the maximum number of wires and devices that can be installed in an electrical box. The NEC provides tables that list the maximum box fill for different box sizes. Do not exceed the maximum box fill for the electrical box. When installing conduit, follow the NEC guidelines for conduit fill. Conduit fill refers to the maximum number of wires that can be installed in a conduit. The NEC provides tables that list the maximum conduit fill for different conduit sizes. Do not exceed the maximum conduit fill for the conduit. When installing lighting fixtures, follow the NEC guidelines for clearance from combustible materials. Lighting fixtures can generate heat, so it is important to maintain adequate clearance from combustible materials to prevent fires. The NEC specifies minimum clearance distances for different types of lighting fixtures. When installing appliances, follow the manufacturer's instructions and the NEC guidelines for wiring and grounding. Appliances require proper wiring and grounding to operate safely and efficiently. Consult the manufacturer's instructions and the NEC for specific requirements for appliance installations. When working with low voltage wiring, follow the NEC guidelines for wiring methods and overcurrent protection. Low voltage wiring is used for a variety of applications such as doorbells, thermostats, and landscape lighting. The NEC provides specific requirements for low voltage wiring installations. Remember that electrical codes and regulations are constantly evolving. Stay informed about changes to the codes and regulations that apply to your work. Consult with a qualified electrical inspector to ensure that your work complies with all applicable codes and regulations. Following best practices for electrical work can help you to ensure safety, reliability, and compliance with codes and regulations. By following these tips, you can become a skilled and knowledgeable electrician.